So in this lesson, we're going to look at what's known as the moment of a force, and we're going to look at what are called levers. So just to kind of recap, so force basically causes objects in an environment to speed up, slow down, change direction. Okay, so that's what's known as a force. In order for something to move, to change direction, speed up, slow down, or even to stop, a force has to be applied to it, and that applies to a lot of things in your environment, for example. Um, And the measure of force, we use this unit called a Newton. So it's just a little bit of recap. So after Isaac Newton. So moment of a force is a particular type of force. So the moment of a force refers to a force causing something to spin. So if we take this example here, so we have a soccer player. So in order for the soccer player to get the ball to move, they have to apply a force, they have to kick it. In the same way, if they wanted to stop the ball, they have to apply a force, they have to trap it with their foot. Now also as well, what the soccer player can do, they can apply spin to the ball, okay? So they can kick it to the side, and what that will do is it'll put a spin on the ball. And that spin is what's known as a moment of force. Okay, so the moment of a force refers to force causing something to spin. So for example, the force that's applied through the kick causes the ball to spin. And that's what we mean by the moment of a force. And also as well, if you take a windmill, for example, in order for the windmill, the propellers on the windmill to move around, the force from wind has to hit or has to be applied to the object. And what that will do is it'll cause a circular motion. It'll cause the windmill to turn in a circular motion. And what humans and physicists have discovered is that they can use this moment of force to their advantage. So they can use these things that are called levers. So a lever, it's working on the same principle. Okay, so it's working on this like spinning force or movement, circular force, and it can be used to do some useful work. So what is a lever? So a lever is a rigid body that is free to move around a fixed point. So for example, if we take here, so we have two parts, so we have this part here, and then we have this part. So you have a rigid body, so this, for example, this beam here is a rigid body, and then you have, it's able to move around a fixed point. So this here is the fixed point that it's able to move around. And this fixed point, okay, so we can see it here in this as well. It has a name, it's what's called a fulcrum. So this is what's known as the fulcrum here. So it's the fixed point in which it can move around. And we're going to look at other examples of levers as well, but we'll focus on this particular example. So basically what a lever enables us to do, so it enables us to move like big objects, and this is just one use of levers, and we're going to look at other examples of levers as well. You come across levers nearly every single day. So basically what it enables us to do, so if you take, for example, this rock here, so in order to move this, we'd probably have to apply, let's say, 200 newtons or even more of force. So think about, like, it would be a huge amount of force that we probably wouldn't be able to, as a single person, like just on your own, be able to apply to a big particular object in order to get the object to move. So what we can do is we can be smart about it, and we can use what's called a lever. So basically what a lever does, you can think about it as it basically amplifies force. So basically it's like it gives us super strength. So it enables us to use a small little bit of force, and then that small little bit of force is amplified. So it's made much bigger. So in this example, for example, we have this person here, and what she does is she applies a small force of 500 newtons, and we can see that that force gets amplified down here at this point to 2000 newtons. Okay, so it has increased it threefold. So it has really increased the force. So what that enables this person to do is to be able to move this bigger object. So that's essentially what like levers do. So for example, if a person wants to jack up a car and lift up a car to change the wheel in it, it's very hard to do that with your hands, just without any tools. But if you use a jack uses the same type of principle. It uses a lever, and it enables you to apply a small force, and that force gets magnified, and it enables you to, for example, lift up a car that you wouldn't be able to do without the lever. So we need to be able to understand how exactly this how levers actually work, and that's what we're going to look at now. So we're going to spend a bit of time just looking at this. So if we take this particular example here, so we have this formula here. So this formula is important. It's important to know this formula. So it's one that we can use when we're dealing with moments of force and when we're looking at levers. So basically the formula, the way that it works is, so you have the smaller force multiplied by the larger distance. So in this case, the smaller force is this here, and the larger distance is this distance here. So it's the distance between the fulcrum and where the force is applied, and then this is like where the load, so if you like, this is like the load, so where the load is applied, okay, multiplied by the larger force. Okay, so the larger force is going to be this force down here, multiplied by the smaller distance, which is this distance in here. So this is the smaller distance. So let's have a look at this, and let's look at how it works. So we take the smaller force, which is 500 newtons. So it's 500 multiplied by the larger distance, which here is in meters, it's 4 meters. And make sure that everything's in the same units as well when you're doing these calculations. So newtons and meters is equal to the larger force, which is 2000 newtons, multiplied by the smaller distance, which is one meter. Okay, so that's what it is. So this side here is equal to this side here. So if we multiply these out, we see that this works out at 2000 newtons is equal to 2000 newtons. Okay, so what we can see is that if we use a lever and if we just apply a small force, that is magnified, so it is. So obviously we can see here that, you know, the longer this distance, the longer the distance, or the bigger, like the longer distance is, the bigger this force we can apply. So the smaller the force we can exert, and we can turn that into like a bigger force. So let's have a look at some other kind of questions that types of questions that you could be asked around moment of a force and around levers. So if we take this question here, so part A, so in relation to the situation illustrated here, answer the following questions. If the student applied a force of 700 newtons on the bar, calculate the force applied at the rock. Okay, so again we use this formula here. So we have, so instead of applying 500 newtons, we are going to apply 700 newtons. So let's do that. So if we have, let's say 700 newtons, so 700 multiplied by, so we're using the same larger distance. So small force multiplied by large distance, which is this distance here, which is going to be 4, is going to be equal to smaller distance, which is 1, multiplied by, and this is what we're trying to work out. So we'll just call it F. We're trying to work out the force. This is the unknown. Okay, so what we do is we just work this out. So we have 700 by 4. So 700 multiplied by 4. That gives us 2,800. Okay, so that's going to be 2,800 newtons is equal to 1 multiplied by force, which is just equal to the force. Okay, so what we can see is that if we apply a force of 700 newtons, okay, if so, let's say instead of applying a force here of 500 newtons, we increase that to 700 newtons. The force down here is going to increase to 2,800 newtons. Okay, so that's a much bigger force than what was originally applied to the rock. And again, that's simply by just adding a little bit more force here on the end of this longer side of the lever. So again, you can see basically what's happening is that the force here is being magnified. by this lever. And that's essentially like what lever does. It magnifies a force. So that is part A. And now what we want to look at is this question here, so part B. So part B. So what it's saying, what it's asking is, if the student wants to apply a force of 6,000 newtons to the large rock, what force must she apply to the bar? Okay, so we're trying to find out, this here is going to be the unknown, and down here we're going to apply a force, we want to apply a force of 600 newtons. So what we can say is that, so we let a letter just represent the unknown, so force, so F is going to represent the letter, so the smaller force multiplied by the larger distance, so the distance here stays the same, so 4 meters, is going to be equal to 1 multiplied by, and we want to apply 6,000 newtons down here, so 6,000 newtons. So the question really is, if we want to get 6,000 newtons down here at this end of the lever, how much force do we have to apply up here at the other end? So we just write it out like this. So small force, we just represent it as F, that's what we're trying to find out, multiplied by the larger distance, which is still the same, the distance here, which is 4, multiplied by 4, is equal to 1 multiplied by 6,000 newtons. And this 6,000 newtons is what we want to try and, that's what we want to get at the end. So again, we just work it out. So F multiplied by 4 is just going to be F4, is equal to 1 multiplied by, is just 6,000. And then, so this is just using like simple basic algebra. So for example, if 2x is equal to, let's say 2x is equal to 10, in order to work out what x is, we have to divide both sides by 2. And x then is equal to 5. So the same principle is happening here, except we're just using f4, or 4, we could even write that as 4f. So in order to get rid of the 4 on this side, we have to divide this by 4. And then we have to divide this side by 4 as well. And what that will do is these two here will cancel out, 4 and 4 will cancel out, and you'll be left with F is equal to 6,000 divided by 4, and we can just use our calculator. So 6,000 divided by 4 is equal to 1,500. So it's equal to 1,500. And it's going to be in newtons. Okay, so what this tells us that if we want to get, let's say 6,000 newtons down here, okay, so we want to get that big force down here, on this end here we have to apply a force, we'd have to apply a force of 1,500 newtons. 1,500 newtons. Okay, so these are kind of calculations that you could be asked in relation to working with levers, and in order to work out like the type of force the levers can apply. So this is a very basic lever, and again you can think about levers as their force amplifiers. What they do is they take a force and they amplify it, so like what we've seen here in all of these examples. So what we're going to look at now, we're going to look at some other examples of levers, that like just levers in everyday life, and levers are very useful because what they do is they enable us to get tasks done with that would like require an awful lot of force. So remember, all of that force takes energy and strength, and in order for us to be able to get over that, what we can do is we can use tools that are essentially levers, and what they do is they magnify the force that we can apply, and that enables us to do all kinds of useful things and useful work in our environment. So essentially what it does is it gives us like super mechanical strength. So here are a whole host of other types of levers that you would come across all the time in your environment. So there's basically different types of levers. Okay, so this is the one that we've been looking at, for example, here in our question. So you have this type of lever. So again, think about the parts. You have the fulcrum, so that's the point at which the lever can move around in. You have the load. Okay, so it's the part like where basically the force is sent to, and then you have like this part which is the effort. So this is like the part where the person applies the force. Okay, so you've this type of a lever. Okay, so you have all the parts. You have the part where you put the effort, you have the fulcrum, and then you have the load. And if you think about, these are everyday examples of these type of levers. Okay, so you have this one here, for example. You have, like, if you're opening up a tin of paint, you normally would use a long, like a screwdriver, for example. So you'd stick it underneath the lid, and then this part here that comes into contact with the side of the tin, this is like where the rotation happens. Okay, so that's the fulcrum. This is where the force is going to be applied to the top of the lid, and then this is the effort. So it enables you to pull off the lid. Now think about it, like, you might not even think about that, but the amount it takes a lot of force. So if you were to try and do that with your fingers and pull the top of this off with your fingers, you're not going to be able to do that unless you have super strong fingers. But again, that just shows how levers enable us to magnify force. Similar, likewise, then as well, if we take, for example, here, so you have a scissors. So again, you have the point of rotation here, which is the fulcrum, which is this point here. You have the point where you apply the force, which is the handles, and then you have where the force goes to, for example, the load. Okay, so that enables us to do useful things like mechanically cut through paper. And then again, you have this example here. So if you're trying to lift a heavier load, you can use a lever like this and a fulcrum. This here is another type of lever. So again, it's still a lever. You have your fulcrum. Okay, so you have the point of rotation. You have where the force is applied, and then you have where the force is sent to, and then you have like where you apply the force. Okay, so exactly the same principle, but just slightly rearranged. So again, in this case, the load is in the middle. Okay, the fulcrum is here, the turning point is here, and then where the effort is applied is here. So really, a common example of that is a wheelbarrow. So if any of you have, or you may work during the summer as a labourer, a wheelbarrow is going to be your best friend. It will help you to carry huge loads with very little, well, with less effort than it would take to carry the loads if you were to just carry them around in your arms, for example, if you were to carry blocks or cement or whatever. The same principle then with a nutcracker. So imagine if you try to crush a nut like with your fingers, the hard ones like a walnut. So again, you have the fulcrum, which is up here. You have the place where the load is applied, which is in here, and then you have the place where you apply your effort, which is here. And then again as well, the same with a car door as well. So think about the weight of a car door, and they're quite heavy, but we can easily open and close them. Like when we open and close a car, when we open and close the door of a car, we don't even think about it. So again, you have the fulcrum, which is up here, the hinges. You have the load, which is here, and then you have the effort, which is here. So imagine if this fulcrum was not there and you had to try and pull the like open or hold that amount of mass in that position. It takes a huge amount of effort. So this again shows how levers can massively amplify force. And then another example is this one here. So again, you have the fulcrum is up here. So this is like the pivoting or the turning point. You have the effort, which is where we apply the force, which is here. And then you have where the force is sent to, which is here as well. So this is a shovel. So think about how easy that is. So other examples of this type of a lever. So if you take a brush, for example, the same principle. The turning point is up here, like where your hand is. The effort is applied here, and then the load is applied down here. Same with the tweezers. For example, the fulcrum is up here, the effort is here, and the load is here as well. And the same with a fishing rod then as well. So the fulcrum is here, the effort is applied here, and then the effect is applied here as well. So these are all examples of levers, and this is like just showing you, for example, what like moment of force. So basically, moment of force is like a circular. It's a force that's applied, but it causes an object to move in a circular direction. Okay, so that was levers and how levers work, and then some common types of calculations that come up in relation to levers. Okay, thank you for listening.